environment. Okay, so the first point comes how you represent. Okay, for example, if we are working bioinformatics, we are focusing on biomolecules or any other small organic or inorganic compounds, doesn't matter. So how we are going to represent the structure? So here comes the representation of a structure from physics point of view, chemistry point of view, and computer science, maths, everything included, because we are using physics, because there is a force or attraction or there is any kind of action is involved. We are using chemistry because we have to represent the structure with its own native physicochemical potential or biochemical potential. We are using maths because we have to represent all these things in a mathematical expression. Okay, some polynomial or something. And we are going to use the computer science graphics because the entire thing we have to feed in and we have to do a calculation that should give us some value. So execution is via the computational science. We are implementing the application of mathematics, physics, and chemistry. Okay, so all put together, the entire representation. Now we are saying this as a force field. Only one term, but this has full complication or full information. Okay, so now I am coming to the issue saying that the next thing is that by understanding the word, what is force field? Now we are going to see that what are the types of force field we can expect. See, force field in the sense it is a bonded system or a non-bonded system. This is the main to classification in biology. See, if you are trying to understand a particular action of a biomolecule which is completely bonded, okay, when we talk about see, when we are talking about the amino acids, we have units. Okay, so you can also have kind of additional information. We have amino acids, whether it's a polar, it's a non-polar, or electrically charged. Okay, this is the main classification. But even in this, we can go with whether it's acidic or basic or whatever. Okay, ma'am. So the thing is that what I'm trying to convey here is, okay, we have some amino acids which is going. Is making a peptide bond and it is continuously forming. Okay, so this amino acids, when it is, you cannot write this as a straight line. When you are making every bond, what happens is this is inheriting some kind of secondary structure. Okay, so the array is formed. The array of the primary amino acids is formed 100% by the covalent bond or the bonded interaction. Okay, but when you keep some 50 amino acids in straight line, it always never be in planar or never be as a linear one. What happened? It is really trying to accumulate some kind of folding nature. Okay, this folding is done by suppose one nitrogen here with maybe one amino acid, second, third, fourth, and the fifth. Okay, this first amino acid and the fourth. This is, if I say I is equal to 1 and this is equal to I plus 2, I plus 3, I plus 4. So this is I plus 5. So in between you have 3. So 1, 2, next 1, 2, 3, the fourth one it is interacting. It is making a hydrogen bond. This hydrogen bond is not a covalent bond. It is a non-bonded interaction. Okay. So in any biomolecule, the main more than 90% of the interaction is by the hydrogen bonding network. Now we are seeing the hydrogen bond within the same protein. But In reality, the same amino acid is covered by counter ions or some other biomolecule or the water medium, whatever there. So in that case, what will happen? The same amino acid can also make hydrogen bond with a nearby other electronegative or electropositive atoms via hydrogen bond. It can be via hydrogen bond, it can be some other van der Waals or something. So all these types of interaction we are going to see. So to classify these interactions, we begin by one is the bonded interaction, the other one is the non-bonded interaction. You all follow what I say?
Yes, ma'am.
Fine. Now we are starting with the bonded interaction. Students, there is nothing strong, very difficult in this. It's all like a story. Okay, Schrodinger equation. Okay, the Schrodinger equation I'll skip. There is no meaning. Just we will go with the bonded. Okay, but this thing I will explain at the end of the class. Okay. So we are going to understand now the bonded interaction. Okay, bonded interaction in the mean. Okay. Suppose if I take this system, okay, what happens? Let me start understanding the bonding from nitrogen to hydrogen, nitrogen to carbon, carbon to oxygen, carbon to carbon, all these things I put. So what I have to do? Let me put 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the thing is that 1 minute, I'll just do this. Okay, I'm starting from 1. Okay, what happens is I will not copy and paste and waste the time, but I have to do this at least for 4 atoms. Okay, so now I'm simply what I'm doing is I actually make this. I'm numbering it because I in the computer program I have to give some feedback. I have to represent who is the person, and so some basic information I'm giving. So what I'm thinking, suppose if I take the amino acid, what happens is immediately I have to represent the electronic configuration, the hybridization, what it is using. So what is the this one? N will have one more this thing. So it is a what is this sp2 or sp3? What is the hybridization? Are you guys familiar with the hybridization?
Yes, ma'am.
Yes,
Okay,
ma'am.
so this is N3. One you will have one more connection. So it is a sp2 only will have 3 bonds, right? Okay, correct.
Yes, ma'am.
Okay, so what happens if you go and look for the force field? Okay, again I will go to this. I think everything is there in my slide, but this is one such example. I think, yeah. So what happens is we have one molecule, which don't worry, which molecule doesn't matter. So I have a chlorine, nitrogen, carbon also C1, C2, C3 means like if I come like this, see I have put no, this will be C3, then this is C5 and like that it number goes, okay. But what happens when this N is connected with the sp2 hybridization, one proton, one carbon, probably another carbon, all put together by influencing this atom, this N will have its own charge. It will not have its, see, the native charge of a N is different. When it is bonded with other elements, then N is different. Okay. Similarly, when a proton hydrogen, if you see as a what is that molecule H2, the nature will be different. But when it is bonded to amino acid, the charge distribution will be closer to nitrogen because it will get hybridized to some extent, neutralized to some extent. So the charge value is getting different. When carbon binds with this is what is this? sp3. So two hydrogen one double bond and another two bonds. So accordingly, but the same carbon which is connected will have a different charges because this is connected to proton and this is connected to nitrogen and this is connected to carbon. There is no high electronegative atoms like here in the system. So the carbon charge here, C3 charge will be different from C5. You guys are understanding? Say yes immediately.
Yes, ma'am.
Okay, otherwise, I have to wait and it will delay your time. So the problem here is, I'm coming back. So now we have, even though it is a carbon, the charges are different. Even though it is a nitrogen, charges will be different. So coming back to this, every carbon we number and we get the proton, and accordingly, we have to represent it in a different way, in a force field. Whether this Na has something, this C3 means this C connected to C, it will have a electrostatic potential of 0.4. When C connect this C alpha, in the amino acid C1 is always the C alpha, right? So that has a different charge. The C alpha in C3 position is different charge. The C alpha in C4 position is different charge. The carbon connected to hydrogen is different. The hydrogen connected to the Ca, that is different. So every charge is getting disturbed by the bonding, covalent bonding. Okay, so first priority is immediate connection, that is one atom getting interacted with the other atom. So our worry is always first atom to second atom. So if a molecule is a macromolecule, it has a n number of atoms, but we begin our representation by considering the first atom as a small representation of atom, a charge, point charge. Then we will think that, okay, hydrogen is also another point charge, but this hydrogen is interacting with the nitrogen, but this is making a covalent bond. 1 minute. Daddy, நான் 10:30 வரை கிளாஸ்ல இருக்கேன், நான் அப்புறம் கால் பண்றேன்.
Okay, and the email மட்டும் பாரு.
Okay, Daddy. Okay, so now we first begin our imagination with one dimension. With the one dimension means one particle. Then we are beginning that, okay, this is also another point charge. This is interacting with the nitrogen, but this is forming a covalent bond. So we consider this as a bonded interaction. So now 1 and 2 is over. Now another issue is, okay, third atom is coming to join. This is also a bonded interaction, but now our imagination is little more extended. That is, this is 1 point charge, this is 1 point charge, this is 1 point charge. This is stage 1. What is the stage 2? That is, hydrogen is interacting with this. So 2 particle interaction. So this is one. Another 2 particle interaction is what? The carbon interacting to nitrogen. So we have now 2 types of 2 particle interaction, 2 atomic interactions, correct? So one is the NH, the other one is the NC. So this is stage 2. When the stage 2, considering this point charges, we are adding one more information of the bond information. You all agree with this? This is very, very critical. This is a very, very basic, and if you understand, nothing is difficult, right? Okay. So in the stage 1, you are considering a point charge. In the stage 2, you are considering 2 point charges and getting interacted as a bond. So you have this bond and you have this bond. What happens if you extend that 2 atom system to a 3 atomic system? We are getting, apart from this bond, we are getting one more parameter, that is the angle. Understand? In a 3 point system or 3 atomic system, you have one more parameter called angle. Now I'm extending to the 4th atom. Now you have 4. What happens is, with respect to the CN bond, keeping this CN bond in one particular orientation, the H will move, the oxygen or when if the carbon is relaxing, this oxygen will also change position. What happens? Let us assume the C and N is fixed and the oxygen is relaxing and the proton is relaxing. This is 4 atomic interaction. This is one angle. We can make it, that is, you superimpose this 1 with a 3. Then means your structure will be like, you have sorry. You will have a structure where the 3 is interacting with the 2, as well as the 3 is making another angle with the 4. What we did now is like we made it like C and N together. That is, here now you have a 3 and 1 together, because we are fixing this as a single point. Now we are worrying about the orientation of 2 with respect to the orientation of 4 by keeping this 3 and 1 as a single, by considering this as a single point. We are understanding the angular deviation of 2 with respect to 4. This is our imagination, but in reality, this is a 4 atomic system. 1, 2, 3, 4 is there. So this angle we say dihedral angle. This angle can go from planar to a non-planar. What is a planar to non-planar? Suppose if I say, okay, this is my, what is that? You guys are following what I'm saying?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Wait.
Ma'am, do you mind if you go a bit slow?
I have to go a bit slow, huh?
Yes, ma'am.
Okay. What you couldn't understand now, you tell me, I will repeat.
Ma'am, how the bond angle is considered in, like, how is it 3 and 1 considered as a single point, and how does that affect the bond angle between 4 and 2?
Okay. So I'm just coming. Okay, what happens? You take a pencil in your hand, okay? Now, and at the tip of the pencil, you keep your 4 fingers from 2 hands. Are you doing that?
Yes, ma'am.
Oh my God, I should redo. Oh no. Okay. What you have done now? Okay, can you switch on your video?
Oh, ma'am, me?
Yeah, you switch on your video. I will also switch on my video.
Okay.
Shruti, my pencil put short or pencil put. Alla the marker put. See, you take a pencil, okay, and I'm holding this with my 4 fingers. All of you are seeing, right?
Yes, ma'am.
Okay. So now I consider this is A, this is B. This is first atom, second atom, third atom, and this is the fourth atom. Okay, now you imagine my left hand, this is my left hand, and this is my right hand. I am starting from the bottom of the forefinger and coming to the top, and from the top to bottom of the right hand forefinger I am going. Correct. The problem is I want to locate the bottom or the atom 1. Okay, now I have 4 atoms connected together. I want to understand the fourth atom, the orientation of the fourth atom with respect to the orientation of the first atom. So what I do, in the last class I explained, if we have to reduce the complexity, we can go with the, what is that, reduced mass. So here I am doing a reduced mass concept with atom number 2 and atom number 3. So now you imagine I have the bond here, but I cannot, I am trying to merge. So I am trying to merge this 2 and 3, but still I have 1 separately and another 4 separately. Now I can talk about the orientation of the first and the fourth. You understand?
Yes, ma'am.
I can also come like this, I can also come like this. So what is the degree? So if it is like straight, or if if this is this way, it is 180 degree. If this is another way, it is 360 degree, correct?
Yes,
So dihedral angle has a very good flexibility. That is what your protein amino acid is like moving and getting folded. You understand?
yes, ma'am.
So for our imagination, I have fused this 2 and 3. So we are talking about the orientation of the first one with the fourth one, keeping this center 2 as a reduced mass. That's what in my PPT I have put 1, because the numbering here is I started from here only 1. If I start this, okay, from what I explained now, okay, if I say like this, you will understand. Now you will have 2 and 3 fused. Right. Okay, now you have 2 and 3 fused and this is 1. Now you are able to understand?
Yes, ma'am.
Okay, so
Yes,
that's
ma'am.
what I was trying to draw here. Because I am going to fix this 2, 3, then I will put this 4 there. Then what happens is, if this is there, same plane, dihedral angle. Hello? Okay. So what happens is now we are going to worry about the the system is now has 4 particles, that is 4 atoms, and we are worrying about locating the 4th atom with respect to the first atom. So in the first point is we are worrying about locating atom number 1. Second point, we are worrying about locating the atom number 2 with respect to 1. That means you have its own charge, you have a bond. Third thing is that you have to locate the third atom with respect to the first atom, where your second atom is in between. So the bonding is with the 2 and the angular representation is with 1. Understand? Now I am talking about the locating fourth atom with respect to with respect to 1, where 2 and 3 are the intermediate atoms. I am taking a reduced center of mass and locating this 4. So I am getting a new term called a dihedral angle. You guys are okay with this?
Yes, ma'am.
Any doubts with anybody? Anybody who has a doubt, you can raise your voice, you can ask. I will proceed, okay? I will proceed now. Okay, so now we are going to 4th atom. Similarly, we will go with the 5th atom. Okay, but if you see that this is a connected angular. There is some kind of non-proper 1 to 4 interaction will be there. That is, we say improper. How? Because now you have suppose if I take this hydrogen, okay, and what happens is like you are taking with this, what is that? What plane I can take? I can immediately take these two only. Okay. The problem is the plane of ketone with carbon will be in one plane, and the plane of NH with this G will be in another triangle plane. But fourth atom, if you consider this H and 4, this will sometimes be in a different, what is that? What is that? Polar, non-polar. If I take this picture, yeah, you take this picture, sorry, instead of this picture, you can see this is a planar one and it is giving a, what is that? Some angular variation. Now you see, I'm taking one atom from here and I'm taking one atom from here. This 1,4 angular deviation will be not a regular angular connected one, but still you have 1,4 interaction, like hydrogen bonds are forming, right? So non-bonded nature, your 1,4 interaction will also come in the the protein structure that we normally don't tell this as a dihedral, but we say this as improper torsions. Okay, when we see the structure, we will understand it. So keeping this all things put together, so we are going to understand the bonded system in a bond, angle, dihedral angle, improper torsions, all these components we have to take and fully we have to extend the same analysis. And if you do full thing and we get one mathematical expression that we say that is, this is the force field of this sequence. Understand? You all understand? You all understand what I'm trying to say?
Yes, ma'am.
Yes, ma'am.
So, as a whole, if I tell you the energy from the bonded interaction comes from bond, comes from angle, plane, dihedrals, and another non-bonded interaction. These components, one by one, we are going to understand now. This is for your just a beginning intro. Okay. So, to begin with, I am again going to this slide. What is this? This is the one we saw in the first class. You have a relaxation and the force is proportional to the displacement. Correct? So what happens is, when I give this, okay, I will go with the other slide. See, there's a bond stretching. See, this is graphics. Just to tell you, there's a relaxation in the bond. It can compress, it can expand, like in the previous slide. See, it's a spring, this can compress, this can expand. So, we are using the same concept and the force is what they are talking about here is proportional to the force, and now we are taking the square of the distance, that is in the native when it is staying this it's a L0, okay, but when it is changing it is L. So time dependent change in the bond length is there, that we say it's a L, but without any disturbance the L is there, that is the natural bond length. So this force, the what I'm saying, only the bond extension relaxation, we are using a bond length force field which is proportional. The proportionality is a K constant. The K constant is only for the bond, that's what it is, KL. And we are taking in time dependent change from the native bond length. That means the difference, L minus L0. And we are taking this square to avoid the calculation, the confusion. It's a plus L or minus L. So normally mathematicians, to begin with, they take the square of the function. Okay. So what happens is, whatever you have seen now is one bond, but you have to consider this bond, this bond, this bond, all bonds you have to consider, and you have to sum. So the summation goes with the bond, and this is the force field which we write for a bond when it is relaxing in a structure. KL is equal to L minus L0. L0 is the natural bond length. Force constant KL. Then L, that is your instantaneous variations observed in the bond length. So This is a bonded system. This will show like a harmonic potential. Understand? This will not cleave. When it is cleaving, then it will go to a Morse potential. Morse potential is not, I think, not here in the previous line. Okay, so now this is a bonded system. This will have a equal energy separation and you will have a harmonic explanation. You all understand with this? So if you go back to the first term, now we explained. That is V0 minus V the whole square, the force constant, which is a component in the total force field, total force, the entire force field of the biomolecular structure. So we have now considered bonds now. Let us go and see the angles. Okay. So you see bond stretching, angular, this thing is there, torsion, dihedral variation is there. All these things are here, right? So this is just for your understanding. Okay. So now we are going to the second term. What is the second term? Angle. So now we are moving from the two particle interaction or two atomic interaction. Now we are moving to the three atomic system where we are locating atom number 1 with respect to the atom number 2, considering the 2 is static or it is not moving. So what is the matter? Here this three atomic system has, first point we have to represent this atom, this atom, this atom. Second point we have to represent the two bonds. Third point we have to represent the angular variation. Okay, so angle means what? Again, similar to the bond, we have a native angular deviation, and when these two bonds are relaxing, there is a variation, the theta. So what happens? Again, you consider this as a bond string. So these two angles, atoms will move and say give some variation. So if you take a energy and write it, it is again a parabolic kind because this is expressed only by the bonded network. Okay. So there's no cleavage. Same, instead of L minus L0, we have written theta minus theta 0. Okay. The notations, don't worry about, this is theta. Okay. So this is, we have to go with the entire summation with the angular. Angles means we have to consider first and third, second and fourth, third and fifth, like that. So every atom we have to consider, and we have to avoid the repetition also. There is also some correction in the calculation. We are not explaining that now. Let us understand the beginning concept now. You all are okay with the angles?
Yes, ma'am.
Okay, other students?
Yes, ma'am.
Okay.
Yes, ma'am.
So, how many of you are present today? Okay, 1 minute. I'll finish. Yeah, but I will take another 10 minutes extra. No, I will finish this. Then I will change. Okay. So now here we are seeing the torsion. Torsion is about the dihedral angle. This is what it is, a phi. Okay. So we fix this 2 and 3 and we work out the rotation of the fourth atom with respect to the first. So it is like a rotation. So it comes down, goes up, comes down, goes up. So you have a minima and maxima. So the thing is that it has a periodicity because this is indirectly working like a pendulum only. One full cycle rotation, this may inherit. Okay. So you have angle 0 to 180 degree because every time when it is in the linear. Okay. So 0 to 180 degree. If it is in the planar, it will come, if same position means angle, no change, 0. But when it is coming to the other side, it is 180 degree. Okay. So now the issue for this equation, we are putting one term called cos function because we have a sinusoidal, I mean not a one which I think this is a cosine function. Okay. Because when theta is equal to 0, this has a value 1. That can be only cos. It cannot be a sine. That is what it is, a cos function. But every time when it is moves, atom 1 will show this. Atom 2 may come from this. Atom 3 may come from this. Doesn't know. There is a difference. So we have a phase difference between the atoms. That is taken care of by this delta. Okay. So this cos function of this phi and the phase lag is avoided. So this cause n phi minus delta. Okay, and this function, and we are taking it, dividing it by 2, because every time the same article, the same this thing is going to repeat. Suppose this is from starting to this is one cycle, means the same state is achieved. So they have corrected it by 2. Okay, so every atom will have its own native potential Vn, the force constant. Instead of K, they have given it as a Vn, the force constant divided by 2 into a cosine function. Okay, this is corrected equation. So you simply have to read like this. So 1 plus cos n phi minus delta. Okay, this is your dihedral angle. Is that okay? Yes or no?
Can you repeat this one?
Correct. See, the fourth dihedral angle, what I explained, this equation is, it is like a more or like a pendulum. See, if I rotate this, it can go and come down. So this is a periodic expression. This is a fourth atom. We are working out the location of the fourth atom with respect to the first atom. So the fourth atom will go as a periodic one. So the angle varies from 0 to 180, correct? If first to fourth, if you keep one slide, one scale, and you can calculate, this is a 180 degree. But if this comes here, okay, probably somewhere here, then it will be less than 180 degree. So the entire variation is 180 degree, 0 to 180 degree, okay? And that's what you have a cosine function. To begin with, it has 0 means it has a full, it is having a 0 means 0 angle. The cos 0 is 1. So the function will start from 1, even though your angle is 0. Then slowly it will reduce, because the function when it is cos theta goes from 1 to 0. So 1 to 0. Then it is repeating, same nature, in the one cycle itself. That's what we are dividing this by 2. And what happens is, okay, atom 4 will go like this. Probably atom 5, with respect to the atom, it may have some phase lag. Everything, all of a sudden, the atom will not move like a ready, steady goal, like a running race, because it has its own freedom to relax. Okay. So if you combine all the dihedral system, there is definitely a phase difference in the periodic relaxation. That's what we have we have taken out the periodic differences. So phi is the natural dihedral variation which acquires the cosine. The same cosine function also requires one correction based upon the phase lag. And we are dividing this by 2 to avoid the repetition, because the same nature is counted one time, so we cannot count it 2 times. Okay, so the proportionality constant is Vn. So altogether the equation is k by 2 also you can write, Vn by 2 also you can write, but this function is normalized or corrected as 1 plus cos n phi minus delta. Now it is clear?
Yes.
Okay. Okay, fine. Then, now I told you the improper, no? See, this 1, 2, 3, 4, this system, there's no direct connection, but you have 4 system interaction, correct? Correct. So, this is also showing some angular thing, but we consider this as the improper torsion. There is also corrections for the improper. So, what is this? You can consider this one plane system, the another plane system, and the angle between 2 plane system with a 3 atomic system. Okay, this is one 3 atomic plane, this is one 3 atomic plane, and we have an angle between these planes formed by the 3 atoms. So we keep omega minus omega 0, the whole square. Okay, again this comes between 0 to 1, so it has also the potential like this. So we have seen 4 components in the bonded interactions. One is the bond length, the another one is the angle, the other one is the dihedral angle, the other one is the improper torsions. All these four components makes your bonded interactions. That is fine.
Yes, ma'am.
In the next class, we will be seeing this non-bonded interaction. Before that, how many of you didn't attend my lab, last class lab? You on, those who are absent, please on your video.
Ma'am, it was me.
Who is that?
Ma'am, it's Rohan Ghosh.
What is the problem?
Ma'am, I had a sudden chest pain. It was there for 4 days, but it suddenly got increased that day at 1:30 nearby. So I had to visit the ECG center for diagnosis. The
What
doctor
happened?
had
What
already
was your health issue? What is that?
a sudden chest pain. It was there for 4 days prior to it. The doctor prescribed medicines and asked to go for a ECG if it were within 3 days. So it was moderately fine, but suddenly that day at 1:30 nearby, it got a bit
What,
worse. So
what the
I had to
doctor said,
visit
huh?
the diagnosis center.
What the doctor said? You have any palpitation issue before?
Ma'am, I had been suffering from COVID last during the second wave.
Oh, okay,
So
okay. So you check your cholesterol and your sugar level, please, because I had the
yes,
same problem. Immediately, my cholesterol level and sugar boosted up, and I was not even able to manage, not even able to speak fully. Huh?
yes, ma'am. I had when the sugar level is all fine. The results for the cholesterol is not yet in my hands. I would get it recently.
So you have to immediately stop eating all oily, fatty, everything. Only boiled food, steam cooked food. Very, you have to go with vegetable proteins, not animal proteins. Maybe you can take boiled fish, but not anything else. Immediately you have to reduce your cholesterol. That's a problem also. That was the problem also with me. I didn't know why I get chest pain, why I am not able to breathe and all. And finally, I realized that I immediately, maybe after 2, 3 weeks, I was simply lying down. I thought like, okay, I will take this test. Then I realized that both the sugar level and the cholesterol were raised. Now I changed my food and sugar I am managing. Cholesterol still suffering. So you have to be careful. It's not only for you, those who have affected by COVID, you tell your parents or tell your relatives saying that please tell them to monitor the blood results by taking sugar and cholesterol at least 2 months once because these symptoms are very worse.